In this video, we're going to explore interpretations of multiplication. Now, when we multiply, you'll often see it multiplied with either an X or a solid dot in between them. And what this means is we're going to find the total number of objects if we have A groups and there are B objects in each group. And the result of that will always be called the product. Now let's look at the example of 3 times 4. This means I have 3 groups, 1 group, 2 groups, 3 groups. In each group I have 4 objects, 1, 2, 3, 4, 4, and 4. And if I look across all of my groups and objects, I can count up my number of objects and see that I have 12. 4, 8, and 12. Now, another term you'll hear is called the multiple, and that means if I take any whole number, A, and I multiply it by any other number, and I continue to multiply that number by anything, it'll give me a multiple of A. For example, I can say that 18 is a multiple of 6 because 6 times 3 is 18. Other multiples of 6 would include 12, 24, 30, 36, 42, etc., etc. Now there's different types of problems we can handle in multiplication. One of those is called an array. In an array problem, we have our objects arranged in rows and columns so that every row has the same number of objects and every column has the same number of objects. For example, say I want to know how many pennies are in this picture. Now I can group by rows or I can group by columns. If I group by rows, I'll see that I have 3 groups, and in each group I have 8 pennies, giving me 24 total pennies. However, I could also do it by columns. If I did it by columns, I'd see that I have 8 groups, and in each group I have 3 pennies. And I'd say 8 times 3 is 24. Now if you notice, 3 times 8 and 8 times 3 both give me 24. Thus, multiplication is has a commutative property. I can also do ordered pair problems. In this one, I'm going to be pairing objects together where one object will typically be designated as the first one and the other object will be designated as the second. Often I can use an array or I could use a tree diagram to help me out. So say I want to get dressed and I've got 3 pant options. I've got jean color, khaki color, and gray color, and then I have 4 types of shirts: button, polo, sweater, and t-shirt. I don't know how many different ways can I get dressed. Now, if I start pairing my first item with each of my second items, I'd see that I have jean color with button, jean color with polo, jean color with sweater, and jean color t-shirt. Well, I can do the exact same thing with khaki color: button, polo, sweater, t-shirt. And I can do the same thing with gray: button, polo, sweater, t-shirt. And what I can notice then is that falls back into my array. I have 3 groups, and in each group I have 1, 2, 3, 4, telling me that I have 12 total options. Now say I want to try the tree diagram. In the tree diagram, I'm first going to split into my 3 choices: jean, khaki, and gray. And then within each branch I can then split into my next options of shirts: button, polo, sweater, t-shirt, button, polo, sweater, t-shirt, button, polo, sweater, t-shirt. Now if I look at my groups here, I have 3 groups, and each of those groups had 4 options that were branched off, giving me a total of 12 total options of how I could dress. Last type of problem we'll see is called the multiplicative comparison. And what this does is it compares 2 quantities in which one of those quantities is a multiple of the other quantity. We can use strip diagrams to help us with these. For example, if we have Robert and Samuel and they each have hermit crabs, and Robert has 3 times as many crabs as Samuel. So if we say if Samuel has 7 hermit crabs, how many does Robert have? So let's just start with a strip. That represents how many Samuel has. If Robert has 3 times as many, that means he has to have 3 strips. Now let's actually put in the amount that we know. Samuel has a 7. That means that each of Robert's have to get 7s. And if I do 3 groups of 7 hermit crabs, I would be able to end up with 21.